In this lesson, we're going to continue our review of Algebra 1 concepts that y'all learned when you took Algebra 1. We're going to review how to write equations of lines when we're given the slope and a y-intercept, or a slope and a point, or if we're given 2 points. Now, if we're given a slope and a y-intercept, we're going to use the form, the slope-intercept form, okay? Obviously, you have the slope and you have an intercept, okay? So that's why you use the slope-intercept form. And that form is y equals mx plus b, where m is your slope that you're given, and b is your y-intercept. The other equation that we're going to use primarily is the point slope form. And obviously, as the name implies, that's when you have a point and a slope. All right. And once again, the slope here is going to be signified as m. Okay. Right here. This is your slope. And then your point has an x value, which we signify as x1, and a y value, which we signify as y1. All right. And so then all you have to do is just plug those values in, and you end up with the equation in slope-intercept form. Now, a lot of times when we get to this point, we go ahead and continue on to solve for y to where we end up with the slope-intercept form. So go ahead and pause the video and copy all of these main concepts into your notes. Let me go ahead and erase all my markings. Okay, so copy all this into your notes. Occasionally we'll have horizontal lines and vertical lines. Remember that the horizontal line is a line where the slope is 0. You have a slope of 0. And a vertical line, the slope is undefined because it has a 0 in the denominator. Okay? So because of that, a horizontal line is just simply y is equal to b, where b is your y-intercept, and not only just your y-intercept, but every y um, every y coordinate is going to be the same in that line because it's horizontal. It goes straight across like this y is equal to -3. The vertical line, remember the slope is undefined. It crosses the x-axis right here. Okay, so every x-axis will be the same in a vertical line. So in that case, you would have x is equal to a, or in this case, where a is -2, x is equal to -2. So pause the video and copy these notes into your notebook. All right. All right. So for the first couple examples, um, the first thing says to write an equation in slope-intercept formula of the line with a slope of 6 and a y-intercept of -3. So once again, we have a slope and a y-intercept. So we're going to use the slope-intercept form. Okay, and the slope is 6, so that gets plugged in for m, and the y-intercept is -3, which that gets plugged in for b. So when we do that, we end up with y is equal to 6x plus negative 3, and simplifying it even further, y is equal to 6x minus 3. Now, a lot of times we want to go ahead and rewrite it as in the simplest form. And now we also, it asks us to graph the line. So we know that the y-intercept is negative 3. So that's the y-intercept is for the point where it crosses the y-axis here. So we come down here to negative 3, and we put our point at negative 3. That's usually where we're going to start. Okay, and then our slope is 6, which remember is rise over run. So that would be 6 over 1. So that means we come up 6, 1, 2, 3, 4, 5, 6, and then we come over 1, put a dot, come up 6, 1, 2, 3, 4, 5, 6, come over 1, and put a dot. And a lot of times, remember technically we only need 2 points to draw a line, but if we can draw more than that, we certainly can. Okay, and then you want to draw a line through those points, and as steep as this line is, it's a little bit difficult to draw a straight line. So actually, if I just go here and just draw a straight line through here, that would probably be the easiest. All right, next one. It says write an equation in slope-intercept form of a line with a slope of negative 1 and a y-intercept of 4, and then graph the line. So y is equal to mx plus b. Slope-intercept form, we have a slope, we have a y-intercept, so that's why we use a slope-intercept form. Our slope is negative 1, and our y-intercept is a positive 4. Okay, so we have y is equal to negative 1, x plus 4. Now, most of the time we don't bother putting the 1 in, so most of the time we would just simply write this as y is equal to negative x plus 4. And when we go to graph this, once again, my y-intercept is a positive 4. So come up here to positive 4. 1, 2, 3, 4. Start there. And remember, rise over run. So that would be negative 1 over 1, or 1 over negative 1. Okay? So if we have rise over run, a negative rise means you come down. A negative run means you go left. So start here. Come down 1. That's your negative 1. Come over 1. Okay. Come down 1. Come over 1. So there's that. You can do it that way. Or if you do it with using the other one, you have a rise of positive 1 and a run of negative 1. Rise of positive 1 and a run of negative 1. So you would have something that looks like that. This line is a little bit easier to draw because the points are closer together. Okay? The next example that we're going to do is, it says to write an equation in point slope form. So it tells us we're going to write it in point slope form of a line whose slope is 3/5 and that contains the point negative 10, 8. So we label our points x and y, x1, y1, and we know that this 3/5 here comes over to the m. So we have y minus y1, which is 8, okay, is equal to 3/5 times x minus x1, which is negative 10. All right, so we can see here that we have this double negative here, okay? So let's just change that to a plus. Y minus 8 is equal to 3/5 times x plus 10. All right, now we apply the distributive property to the 3/5, and we end up with y minus 8 is equal to 3/5 times x is just simply 3/5 x plus 3/5 times 10, and I'm going to write the 10 as a fraction of 10 over 1. All right. Now you can either cancel the 5 and the 10 out, or you can just multiply straight across and simplify it that way. Y minus 8 is equal to 3/5 x plus, if we multiply it straight across, that's 3 times 10 is 30, 5 times 1 is 5, all right? And we know that 30 divided by 5, this right here, it simplifies down to a 6. So we end up with y minus 8 is equal to 3/5 x plus 6. Okay, because this here simplifies 30 divided by 5 is 6. We add the 8. Add the 8 to both sides. Remember, we can only add the 8 to the whole number because it doesn't have an x, so it's not a like term. We end up with y is equal to 3/5 x plus 14. Now, if we look, it's asked us to graph the line, and if we look over here, we only have 10 lines along each of the axes. So we can, one of the things we can do is, we have a y-intercept of 14 right here. That's our y-intercept, okay? But what we can do is we just count by twos. So 2, 4, 6, 8, 10, 12, 14. So 14 right there is our y-intercept, okay? And then our slope is 3/5. And because of the fact that the slope is a ratio, we can just count up 3, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. Put a dot, okay? We can also do a double negative. So we could go down 1, 2, 3, and over 5. 1, 2, 3, 4, 5. Put our dot, and then we can draw a line through all three of those points. Okay. Sometimes that's what we have to do if the lines don't match up, as far as we don't have enough lines in our coordinate plane. Okay. Write an equation in point slope form of the line whose slope is 1/3 that contains 6, -3. And I just thought about it, the fact that back here it asks us to write in point slope form. So technically, right here would have been the actual answer to the question. We went ahead and solved it in slope-intercept form. All right. This also asks us to put it in point slope form. So that's the y minus y1 is equal to m times x minus x1. All right. Slope is 1/3. Okay. So this becomes 1/3. The x, this is our x, this is our y. So this becomes x minus 6. Come over to the left side, y minus -3. All right. Once again, we have a double negative here. That's y plus 3 is equal to 1/3 parentheses x minus 6. If we distribute the 1/3 to the x, we end up with 1/3 x, and the 1/3 to the 6, so minus 1/3 times 6 over 1. Okay. We're going to keep the y plus 3 for the time being. So y plus 3 is equal to 1/3 x minus 6 over 3, because when 1 times 6 is 6, 3 times 1 is 3. All right, 6 over 3, this simplifies down to 2. We have 1/3 x and y plus 3. And then when we solve for y, we subtract 3, subtract 3, 3's cancel out, we're left with y is equal to 1/3 x minus 5. And once again, this is slope-intercept form. If we would have stopped just simply at point-slope form, we would have stopped at this point right here. Okay, I went ahead and solved for slope-intercept form because of the fact that we're going to graph this particular equation. So y-intercept is -5. 1, 2, 3, 4, 5. -5 with a slope of 1/3. Okay, so that's a rise of 1 and a run of 3. Okay, and if we do another one, a rise of 1 and a run of 3. Okay, that gives us 3 points, and you just draw a line through all 3 points. All right, so this next equation, we actually have 2 points, okay? But it gives us a hint that we're going to write it in slope-intercept form, but we're going to use the point-slope form. The slope-intercept form, that's what we've sort of been doing by default. And when we're talking about point-slope form, obviously, remember, we got to have points, and we do. We have 2 of them over here. But we also got to have a slope, and we're not given the slope in the equation to begin with, but we know that we can use 2 points to find the slope by using the slope formula of slope is y2 minus y1 over x2 minus x1. All right, so when we do that, we remember from the lesson last week, we want to label them, and I'm going to label this x2, y2, x1, y1. All right, and when we plug that in, that gives us 9 minus 0 over 4 minus -2. Okay, this turns into a plus. 9 minus 0 is 9. 4 plus 2 is 6. Both 9 and 6 can be divided by 3. Okay, to simplify it, 9 divided by 3 is 3. 6 divided by 3 is 2. So our slope is 3 over 2. So we're going to plug that into y minus y1 is equal to m times x minus x1. Here we know that our m is going to be 3 over 2. And then we just have to pick one of the points up here, and it doesn't matter which point we pick. I'm going to pick the second one. I'm going to pick this one just simply because it has a 0 in it, and that makes it a little bit easier, because then we have y minus y1, which is 0, is equal to 3 over 2 times x minus -2. All right, once again, double negative turns it into x plus 2. So we can simplify y minus 0 just simply y is equal to 3 over 2 times x plus 2. All right, when we distribute, okay, 3 over 2 times x is 3 over 2x plus 3 over 2 times 2 over 1. Okay, don't forget the y in the front. Okay, so here we have a 2 in the denominator, 2 in the numerator. So those two just cancel out. We end up with y is equal to 3 over 2x plus 3 over 1, or just plain old 3. All right, so that would be our equation for a line that contains 4, 9, and negative 2, 0. All right. All right. Write an equation slope-intercept form for a line that contains 3, 2, and 6, 8. Okay. Once again, label them. X1, Y1, X2, Y2. Remember last week I said I normally just sort of gotten into the habit of having the larger numbers be your X2 and Y2. Okay, so then we go 8 minus 2 over 6 minus 3. 8 minus 2 is 6. 6 minus 3 is 3. 6 divided by 3 is 2. So we have a slope of 2. And up until this point, our slopes have all been fractions, but in this case, slopes can also be whole numbers. So that we generally don't refer to slopes as decimals. All right. So plug it into our point slope form. Y minus y1 is equal to m times x minus x1. All right. We know that our slope is m is 2. Okay, and x minus, it doesn't matter. Let's just choose, because we've already got this labeled as x1, y1. Let's just do that. So x1 is 3, and we end up with y minus 2. All right. So then when we distribute, 2 times x is 2x minus 2 times 3, which is 6. We end up with y minus 2. Okay, solve for y. Plus 2 plus 2. So y is equal to 2x. Negative 6 plus 2 is negative 4, or minus 4. So our equation is y is equal to 2x minus 4. All right, this next one gives the points 5, negative 2, and 0, negative 2. All right, so once again, let's say this is x2, y2, x1, y1. All right, so we plug it in. Negative 2 minus negative 2. And then we have 5 minus 0. When we do the keep change here, this turns into negative 2 plus 2, or the double negative, however you want to look at it. Negative 2 plus 2 is 0, and 5 minus 0 is 5. So now it doesn't matter at all what is in the denominator, because if we have a numerator of 0, our entire slope is 0. Now if you think back to the previous lesson, we said that if we have a line that has a slope of 0, this means that this is a horizontal line. That's a horizontal line. And in this lesson earlier in your notes, you said a horizontal line is one that the equation is always y is equal to whatever our y values are. So this would be y is equal to negative 2. So we already know the answer. If we want to plug it into the point slope form, y minus y1, we'll do that just to show that the same thing. M times x minus x1. All right, when we plug in our values, y minus y1, well, we'll say that is a negative 2 is equal to m, which is 0 times x minus 0. All right. Distribute. 0 times x is just 0. 0 times 0 is 0. And we end up with y plus 2 is equal to 0. Okay, so we say y plus 2 is equal to 0. Solve it. We're already adding, so we subtract 2, 0 minus 2, and y is equal to negative 2, which we already knew. We already knew that because of the fact that we had already identified that it was a horizontal line. All right, the last thing that we're going to work on in this lesson is coming up with the equation of a line when we have a graph of the line. And we're always going to use most of the time we're going to use the form of the slope-intercept form of y equals mx plus b. Okay, so we're talking about b being the y-intercept. Okay, when we look at that, the y-intercept is simply the point that it crosses the line. In this case, that's 1, 2, 3, 4, 5. Sorry, our y-intercept is 5, positive 5. Okay, our slope. Okay, so we know that we know that point right there, and we know that here's another point. Okay, and you can pick any points that you want to. Here's another point here. Here's another point here. Here's another point here. Okay, so there's points all along this line that we know the exact coordinate of. Okay, so when we look at this, well, first of all, one of the things to look at is that we see that it has a negative slope. The line has a negative slope, and we can see that because our rise is 2, and our run is one space to the left, which is a negative 1. Okay, so y is equal to 2 over negative 1x. Well, this just simply simplifies down to negative 2x plus 5. All right, and the last example that we have says write an equation. Well, our y-intercept is right here. Okay, so y is equal to mx plus b. All right, the y-intercept is at plus negative 1. All right, our slope is a rise of 1. Okay, if we look here, right here is where I'm going to go. We could go there. We could go down here. So it doesn't matter exactly where you want to go. There's points all along here, but I always pick the one that's closest, and usually the one to the right. But it doesn't matter. Okay, so here we have a slope of going up 1. Okay, right here, going up 1, and then we have a run of 1, 2, 3. Okay, so 3 in the positive direction. Okay, and so we have y is equal to 1/3 x plus negative 1, and we would normally rewrite that in simplest form of y equals 1/3 x minus 1. Okay, so that does it for this lesson. Take a look at your notes, and if you have any questions at all, please make sure you get in touch with me. All right, have a good one.